Hi everyone. So here is chapter 4, part 4, digital modulation, PCM with Madam Hafiz. So we now know we have 3 steps in PCM: sampling, quantization, and encoding. So before that, first thing we need to know the bit rate. Okay, according to the Nyquist system, the sampling rate at least 2 times the highest frequency contained the signal. So we know that Fs equal to 2 FM. So here is the frequency sampling is equal to 2 FM. So we can say that the sampling rate, the Fs equals to 1 over Ts. So where Ts is the sampling interval. So Ts equals to 1 over Fs. So the bit rate is used to describe digital signal. The bit rate is a number of bits sent in 1 second and is expressed in bit per second. So the bit rate Fb is equal to Ff times with n. Okay. So example 2, refer back to the example 2 PCM system. Let's say the highest frequency on the analog signal FM is 200 Hz. So the frequency sample is equal to 2 FM. So it is 400 Hz. So and since the system is a 3-bit PCM, so for this system, Fb equals to Fs times with n, and this is the bit rate, 1200 bit per second. So let's try to get the, okay. Refer back to the example 2 and 3. Let's now try to find out what are the quantized value and the coded value for each sample until 30 milliseconds. So we know that the sampling rate is 400 Hz. So the sampling time is 1 over Fs, which is 2.5 milliseconds. Thus, at every 2.5 milliseconds, the original analog signal will be sampled. Okay, for this example, every 2.5 millisecond we will sample this original signal. 4.5 until 30. Based on the question, you need to refer the question until 30 milliseconds or until the rest of the signal. So here is the reference table as shown in example 2. So we have level, the quantized value, the voltage range, and the code. So here is the solution for example 4. We have here the graph for the signal, the analog signal. Here is the PCM reference table. So to make it clear or clear view, you need to print out this graph. Okay. So next, you need to build up this PCM table, which consists with the sampling time, the sample value, the quantized value, the PCM code, and the quantization error. So we know that every 2.5 milliseconds, we need to sample this analog signal. So, so let's try 2.5 milliseconds, the first time sample. At 2.5 milliseconds, you can get the sample value here is 2.3 volt, and refer to the reference table. 2.3 volt is belong to this level, level 4. So here is the quantized value, 2.5 volt. Here is the PCM code, which is 100, and the quantization error is quantized value minus sample value. You can put modulus here to get the positive value. So next is 5.0, which is another 2.5 millisecond, which is 5.0 millisecond. So sample this 5.0 millisecond, you will get 3.5 volt, and then refer to the reference PCM table. 3.5 volt is belongs to this level. So the quantized value is 3.5 and the PCM code is 101. And the quantization is 3.5 minus 3.5 is equal to 0. So for 7.5 volt here, refer to this graph, you will get around 3.8 volt. So refer to this reference table. So it belongs to the level 5, and here is the PCM code, and the quantization error is 0.3. For 10 millisecond, so it belongs to 3.0 volt and it belongs to 2.5 quantized value and 100 level, and 0.5 is the quantization error. Okay, we try to another 12.5 volt. Okay, 12.5 volt is 1.5 volt and it belongs to this voltage range, and the quantized value is 1.5 volt and the code is 011 and the quantization error is 0. Okay, next 15 millisecond. 15 millisecond is negative 0.5 and here is 0.5, 0.01 and the quantization error is 0. For 17.5, negative 1.6, negative 1.5 is belong to 000 code and 0.1 quantization error. So you guys fill up another blank table until 30 millisecond. Summary for PSM. So we have sampling time. First of all, we need to calculate the time sample. Before that, we need to know the frequency sample, Fs equal to 2 FM. Okay, next is quantization. We need to know the level by knowing the bit per sample and then the delta V, which is the step size. And after that, we need to know the Vk or the quantized value. Next is encoding, to code the signal, which is the binary value. So two tables that need to build up for this PCM. The first one is reference table, consists of level, quantized value, voltage range and code. The second one for the sampling signal, PCM table, we need the sampling time, the sample value, the quantized value for each sample value, the PCM code, and the quantization error. So that's all for part 4. Stay tuned and thank you.